Up next is Matt Butcher, Principal Software Engineer from Microsoft, and Taylor Thomas, Engineering Director from Cosmonic, who will be talking about articulating their ambitions for WebAssembly community as a whole and show how their open source projects fit in.
Hi, I'm Matt Butcher, and welcome to the National Association of W Lovers, how we can create a thriving Wasm ecosystem. I'm a principal engineer at Microsoft. I run the team called DeisLabs. You might know of us from our work on Helm, Brigade, Krustlet. We started out doing a lot of WebAssembly work, and these days we're kind of transitioning much more into WebAssembly work and some of the other the container management solutions. You can find me on all the social medias at Technosophos. That's what I'm on GitHub, Twitter, Slack, and so on. This is Taylor Thomas.
Yep, and I am a director over at Cosmonic, an engineering director. I actually am a recent changeover from DeisLabs. I used to work on all DeisLab projects, so I am a core maintainer of Krustlet, Bindle, Wagi, all those kind of things, and all sorts of other open source projects. I do a lot of Rust as well, and my social media isn't as coherent as Matt's is, but those are all my social media handles in case you want to find me there. So let's go ahead and explain a little bit about where our title came from. So we'll go ahead and start it.
Oh, the missus and I had a wonderful time.
All right, everybody, settle down. Come on now. Welcome to the weekly meeting of the National Association of W Lovers. We are gathered here today to pay tribute to that great letter, W, and the wondrous sound it makes. Ooh, isn't that lovely? Yeah, it makes the heart pound faster. All right, now, if you'll all turn to...
Okay, that's enough. But if you haven't noticed, if you've looked in the WebAssembly world, the WebAssembly thing really loves their W's, kind of like Java loves their J's and Kubernetes likes their K's. So we're going to talk a little bit about those. So our agenda today is we're going to talk about why wonderful Wasm. Yes, I am leaning heavily into this, so just enjoy it. And then we're going to talk about our favorite W's, the different projects that we work on, and we'll end with our wistful wondering, so what we think the future is going to hold for Wasm and what we're expecting to do with it. So I'll go ahead and we'll just pass it on to Matt to give us a little bit of an overview of why Wasm.
So WebAssembly, as you might have gathered from the name, was originally a browser-side technology. And really, first there was JavaScript. JavaScript was good. We could accomplish many, many tasks in JavaScript. But somewhere along the 20-some-year evolution of JavaScript, a couple of engineers got together and said, okay, what if we tried to build a version of, like a reduced instruction set with JavaScript that we could use in order to run other kinds of languages? And this technology called ASM.js was born. And it was really exciting and interesting. But as the development of that continued, and inspiration accrued upon inspiration, WebAssembly was kind of born out of that effort as a compile target where you could take your preferred language, compile it to a set of instructions that could be executed in the browser. And the W3 was interested and things were standardized and it was very good. Now, these days, pretty much every major browser, most of the minor browsers, and all of the sort of like browser adjacent technologies like Node.js and Dino and V8 all support WebAssembly. So it is a fairly ubiquitous technology at this point. But one might ask, if it's so ubiquitous, why have I, as a front-end engineer, not really heard of it or not really used it? I don't know the answer to that. I never really took a big stab at using it in the browser myself. I like it as a technology, but where it's really exciting to me is not necessarily in the browser, but perhaps on the cloud side or the server side. The thing about WebAssembly that was interesting is that all these things have to be true of a language that's going to run in a browser. The security model has to be very tight, right? You don't trust the code you're executing. You could be, if the browser is just fetching pages off the internet, you don't know whether the piece of JavaScript code you execute is going to be safe. And of course, if you're going to support other languages, you don't want to assume that they're going to be safe either. Nice security model, cross-platform model. Nothing would be popular in the browser if it said you can't access this website except on Linux, or you can't access this website on Windows, or something like that. So there's this cross-platform story that glosses over architecture, glosses over operating system and just says, look, if you can get it to run in the browser, any browser, it's going to run in every browser, plus or minus. Performance is great. On a web browser, every millisecond counts, right? The faster you can get something running in front of your viewer, the better. And language neutrality, that's the big selling point of WebAssembly in the browser. Pick the language you want. It doesn't have to be JavaScript, and you can use it. Now, all of these things together really make a compelling story for the cloud side or the server side as well, right? Same security model, same cross-platform model. Those would be great, not having to rebuild something for every target platform you want to deploy to. Performance model, I mean, it's not so much how fast can we get it in front of the user in performance on cloud side. A lot of it is how low can we shrink our electricity bill when it comes to running things on other people's servers, like in AWS or Azure or Google Cloud. And then, of course, language neutrality is something we all love because we all want to write things in our preferred languages, and we want to kind of have that experience of having the stuff we want, but located in the platform that we would prefer to run it in. So we see those as kind of like big compelling reasons to take what was originally designed as a browser side tool and start using it in a wholly different context, maybe topologically speaking, but in one where the model really, really very closely aligns with what we want as a cloud service.
So with that background, let's talk about what our favorite W's are. What are these projects that we're seeing? As we said, we've contributed a lot to here, but there's tons of things going on in the community, and we're going to go over some of the projects that both Matt and I worked on at DeisLabs, some of the stuff that I'm working on now, some of the things we've seen out in the community that are very interesting, and kind of explain and demo some of those cool projects. So the ones we're going to cover today are these projects right here. We'll talk a little bit about all of them listed here, and just explain at least a little bit so you have a starting point where you can start to go look and investigate the community and learn whatever you want to learn and what interests you in WebAssembly.
Now, the first thing we need if we're going to be able to run things on the cloud side instead of the browser is a WebAssembly runtime that actually runs somewhere other than the browser. Wasm Time is our current favorite. It's a command line client and robust Rust library that can just execute WebAssembly. It is the reference implementation for Wasm32 WebAssembly plus Wagi. And Wagi is the WebAssembly system interface. So when WebAssembly is running in the browser, we might want to bind it to browser objects like document or window or things like that. When it's running on an operating system, we might want to bind it to other kinds of things like file systems, environment variables, the system clock and things like that. The WebAssembly system interface is an effort to standardize how we can attach other kinds of interfaces to a WebAssembly runtime. And Wasm Time is the reference implementation for that. So we love the fact that as that standard develops, we have a core runtime that we can test all of the good new stuff on. It has experimental features as well that maybe aren't part of the WebAssembly or Wagi standards, but are really interesting to try to learn how we can optimize things for the cloud. This is things like caching modules, ahead of time compiling modules, pre-initializing a WebAssembly module so it gets right up to the point where a user needs to interact, and then it freezes, and then it executes whenever the user makes a request, cutting things, timing down from milliseconds to microseconds. It's great. And most of all, Wasm Time right now has a very thriving developer ecosystem as a lot of different, Intel and Fastly and Microsoft and other companies, Cosmonic included, all kind of pool resources together to attempt to make Wasm Time a better runtime. The next project really kind of hits that next stage of development, right? Okay, I got something where I can run a WebAssembly module on the server. Now I need some tooling to help me write a WebAssembly module. As we said, WebAssembly, one of the virtuous things is that you can have lots and lots of different programming languages, all that compile to the same binary target. So we've got Rust, we've got C, we've got Swift, we've got Grain, we've got a litany of languages out there that we can do this with. But each one has sort of a different setup. It needs a different compiler. Rust needs the Rust compiler. C needs a C compiler with the WebAssembly runtime, and so on, right? That can be a little bit of a pain to set up. GitHub Actions, something else you have to set up for every project. There's kind of a number of different things you want when you're starting a project. We've created a project called Wasm, which is a yeoman target, a yeoman generator, where you can type, yo Wasm, and it'll say, hey, what language are you using? You want to deploy this you want us to create a GitHub action for you? Do you want us to store it in an ACR registry or some other OCI style registry? Are you targeting a Hippo application? And you answer yes, no, yes, no, yes, no. My name is whatever, my project name is whatever. And then it spits out a project where all you have to do is open your VS Code editor and click build, and it can already start building everything. You commit it and push it to GitHub, it already starts the GitHub actions and so on. So these first two tools are really designed to get you going with WebAssembly on the server side.
Now we get into some of the efforts that DeisLabs has done, other people in the community have done to really just make WebAssembly useful right now. Wagi is a very new specification, and so there's missing features, and there's things that are hard to do right now, and that's not because it's like a purposeful thing. It's just because that's how standards evolve. You have to figure out how you're going to do all these things. So Wagi was something that at DeisLabs we all designed to create this project that could make it so WebAssembly modules could be used as HTTP handlers. And we use this by implementing CGI. And yes, you heard that right. The 90s called and wanted to be relevant again. So we made it, and that's why it's called Wagi. It's WebAssembly Gateway Interface. And it's an extremely simple configuration and setup. You can either have a bunch of modules locally that you want to run, and you have a small config file that points at them, the routes you want them mounted at, and then you start it up. You can also do it from remote sources, which we'll talk about some of those remote sources next. But it's just a very simple way to write. Basically, it's functions. It's almost like functions as a service, but much more simple in its scope. And it's something that you can use right now to use just plain WASI compiled binaries to build some sort of system or where they need an HTTP response. And that leads to the next one, this idea of a remote source. So Bindle is one of our projects that we really like. In fact, if you're interested in Bindle, Matt and I will be giving another talk in a few days at the Cloud Native Wasm Day to talk about Bindle. Bindle is an aggregate object storage system that we specifically designed for WebAssembly. There's actually some other interesting use cases people have brought up to us, but mainly it's focused on WebAssembly. Now, the reason we created this was because we needed a storage solution for all the cool things that we expect WebAssembly to be used for. But the current artifact registries don't really mesh well with the needs of WebAssembly. They're all very powerful. I mean, we're all used to, for example, OCI and Docker registries and other things. They're very powerful, but they're not really meant for multi-purpose artifact storage. And they don't really work with the idea of you can use multiple WebAssembly modules together at the same time. And so Bindle allows you to create these arbitrary groups, requirements, and connections. We always use the silverware drawer as an analogy, which sounds really dumb, but let go with it here. So when you have a silverware drawer, you have everything grouped together. Everything's in the same drawer, but you have different slots and sets. So you might have forks, you might have spoons, you might have soup spoons, and you might have butter knives and steak knives. And then you have those fancy things that you don't remember what you use for, but you pull them out once every 10 years for some fancy party. Those are all in there, but they're all related. And what you use depends on the situation. So for breakfast, you might need a spoon, but for dinner, you might need a spoon, a fork, and a knife. And so depending on the situation where you deploy it, with WebAssembly modules, it's the same thing. You might need WebAssembly module X, Y, and Z, or you might only need X. There's also this idea of immutability, strict versioning requirements, and artifact signing that are built into Bindle. And so that's one of those projects we use for that storage. And for example, Wagi can pull from it. So those are some of the other things that enable it right now. But the next project is something new and even cooler.
So if we're going to combine all the things we've now been able to do, right? We can scaffold out and build some new modules. We can run them as CGI-like web applications, and we can store and fetch assemblies of WebAssembly modules, aggregates of WebAssembly modules from a Bindle server. What's next? Well, how about if we build a sort of platform as a service-y kind of environment where we can have a nice dashboard and a nice command line client and type in, hey, deploy my app, and it deploys it out there, gives me back a URL, and you can run it. Now, I could talk about this for a couple seconds more, but instead, let's just dive right into a demo video and see Hippo, Wagi, Bindle, all of these in action.
Hi, friends. In this video, we will have an early look at the open source platform as a service we've been working on, codenamed Hippo. Hippo makes it easy for developers to build and distribute applications as lightweight WebAssembly modules, then execute them in a secure sandbox runtime that is extensible and with extremely fast startup times. Hippo enables going from zero to writing an app in your favorite language to deploying a live application in no time, while also freeing developers from platform-constrained APIs and fixed application models that usually comes with a function-as-a-service model. Let's look at a simple demonstration. I just configured the development environment for Hippo locally, and I'm now ready to create a new application. Using the CLI, I scaffold the new app by answering a couple of questions about it, such as programming language, application type, and credentials for Hippo. I can now open the application in my favorite code editor, and we can see for a starter app, it's a very simple application, and it only just returns hello world for each request. I build it and then push it to Hippo using the CLI. In the dashboard, I can see information about it, like when it was last deployed and by whom, and I can access it using the URL I configured when creating the application. If I want to update the application, all I have to do is build it again, bump the version number, and then push it to Hippo. This was a very early look at the developer experience of the Hippo platform as a service. Right now, developers can build applications ranging from static web pages to APIs using cloud services and databases, and AI inferencing using hardware acceleration. Thank you.
So that was an interesting view of what we had with Hippo that was recently released. It's an interesting project, very new. You can go ahead and check that out at that link anytime. It's really just another way to just try to make WebAssembly and its features available now for people to use, just gluing together some of those other things. So now at this point, we're going to get into some of our other the other projects we've worked on and in the community that are kind of alternative runtimes and ways of doing things with WebAssembly that you can do all sorts of insane or powerful, sometimes simultaneously insane and powerful things that you could do with all the WebAssembly stuff that's available. So first off is Krustlet. This is a project that I helped create over at DeisLabs with the team over there. We all worked on it, and it was basically our first project to prove the utility of WebAssembly. It is a Kubernetes kubelet implementation that runs WebAssembly modules rather than containers. And to be clear, there's no containers involved here at all. 0 containers. That's one of those things that a lot of people come back. So are you just running WebAssembly in containers? No, it is not. There are no containers. Containers are not touched with Krustlet. It works with normal pod definitions and Kubernetes objects. The only thing that's really different is just making sure you select the proper node to run it on. And it was meant as a gateway for letting people try out Wasm in a familiar environment to them. So we're talking about like people have really gotten into Kubernetes in the cloud space, but they don't necessarily know WebAssembly very well. So what if it was easier for people to do it together? And that's the main purpose of Krustlet. It was just meant to give people that gateway to try it out. So if you're interested, this is the place to try out WebAssembly if you're just getting started and used to Kubernetes. So let's go on to Atmo.
Atmo is a new project from a brand new startup called Suborbital. And I like the approach that they've taken. So far, we've looked at WebAssembly modules that are largely just stand up a web service and take a request, return a response, that kind of thing. Atmo followed a different intuition and said, what if we could start chaining together WebAssembly modules in a sequence and say, hey, this module will do step A, this one will do step B, this one will do step C, and so on down the line until it had finished whatever the goal was it was trying to accomplish. Now you can assemble basically like this kind of chain of small function-like steps, and many of these will be reusable over time, and each one can do just one discrete piece of a greater application. And this works great when you have step-by-step processing that you need to get done. We are excited about it because this is a lot of the same intuition behind Brigade. This is fleshed out in a very different way, but with the same sort of core intuition in Atmo. So this is a project that we're very excited about and look forward to keeping an eye on in the future.
Next up is Wasm Cloud. So Wasm Cloud is an actor model-based distributed computing system that runs WebAssembly modules. And so it's a very secure system because it's using the security benefits of WebAssembly that we mentioned before, but also it must be signed properly in order to run in the system. It is actually an entire suite of projects and an ecosystem in really. It's more just a full ecosystem with support for multiple languages and connectors that are called capability providers to various types of data stores and sources. And Wasm Cloud is one of the things that can be used to build fully production-ready applications right now that can run anywhere. Because WebAssembly is so small, you can run these things on edge devices and small constrained devices, or you can run them in big data centers. And it's important to note here that you're buying into the platform, so this is very much getting into the platform and using that tool set, but you get a whole bunch of features for free, and it frees you up to focus just on writing your business logic. So let's go ahead and just show a demo of that to kind of give an example of its power. So right here, I'm going to go ahead and just quickly show, I'm not going to show much of this part, but I want to show you, this is all the code that's required for the example I'm about to show. So this is going to be a key value incrementer that anytime something is hit on a web, an HTTP endpoint, it's going to increment a counter inside of a key value database. But you'll notice here, I don't have to do almost anything to connect to the database. There is one line to be able to add on line 17 a key to the database, and then return a response. So this is 21 lines. I'm pretty sure it's just a few kilobytes max. It's probably even smaller to actually build this as a WebAssembly module. So you can imagine in this very simple example how it could scale to something bigger, where now you're just focusing only on writing the things you want to do. So let's go ahead and take a look at what this can look like for us for running an application. So if we were running that key value store that I showed an example of, so we have a dashboard that you can look at. This is actually looking at the underlying OTP and Elixir if you're super curious. But you can use this to start an actor, and so you can actually choose from a registry. And right now, modules in Wasm Cloud are stored in an OCI registry. So right now we're going to go ahead and paste in a reference to that one that we already created. And you can actually scale it up to any number of replicas like you would expect for most distributed systems. So that can be anywhere from 1 to 14 to whatever it might be. And so we're going to scale that up so that there's 15 actors running with this key value store. So that's our logic. But we've said we need a key value store and we need to talk to an HTTP endpoint. So that's where providers come in. And these providers can actually be hot swapped out as you do something with a WebAssembly module. So if you don't want to use Redis anymore, you could swap out a key value implementation for another data store. It doesn't really matter to the actor. It just has to have something that satisfies the contract. So creating a provider, we'll see here, is as simple as going and clicking on that start provider in this dashboard. You can also do this from a CLI, but everybody likes eye candy. So we're going to go ahead and add HTTP server. So that's going to go ahead and load it, and you'll see that it's starting and it's started up and everything's good to go. So that's the simple way for adding an HTTP server. So now we'll be able to talk to this. Now let's go ahead and add a Redis key value store. So you'll see that it has a contract ID if it's a key value store. Then you'll also see that it's started and ready to go. These have a default thing called a link. This link is what allows it to be connected to an actor. So you can connect any actor to any provider using these links. So we'll have to define that link to be able to do it. And I'll go ahead and actually fast forward a little bit through this, where we define the link. And you'll see that you're able to say, okay, we're going to do a key value counter. We're connecting it to the key value counter. We're going to use the HTTP server, and there's the port we're listening on. So you're able to provide the configuration right then. So still, all this logic that you have does not have to know any of this. It just knows that it's going to be able to receive HTTP requests. So then we do the same thing to define a link to the Wasm Cloud key value contract. And so we'll go ahead and I'll skip forward a little bit. You'll see that we added it here, that we added this key value store in. And so now everything is connected. You even got a little bit where some of these went unhealthy for a bit, and the dashboard even shows you the current status of those. So it's a fully supported system. So then once this is all in place, you can actually go to localhost 8080, and then you'll be able to, this is one that we created earlier, so you can see that the counter already exists in the database that we connected to. But if we added something else at the end, we get a new counter. And every time we reload, it's going to increment that counter for us. So we'll see that right there. Now it's going up, and we've hit it 10 times or 11 or 12 times. And so this was all done with those 21 lines of code that were compiled to a very, very tiny WebAssembly module. And so this is really a very powerful system to just get started composing all sorts of business logic together.
I do think, just to kind of tie things together, right? One of the things that you should observe as we go through all of these things is that core technology WebAssembly is really starting to open up a whole bunch of different ways that we can compose different kinds of systems. And you know, the repeated feature of reusable building blocks comes from the fact that WebAssembly is really designed to be that kind of reusable component sort of system. So we're really excited. Here are a couple examples, but we think you'll see a lot more coming out over the next couple of years. But then let's divert to a different direction and talk for just a moment about specialized runtimes. So we've been talking largely about things we want to run in fairly powerful big server environments. But the cool thing about WebAssembly modules, which are small, compact, platform agnostic, easily transported around, is that we could start pushing outside of the data center and start connecting other devices in here. And this is where some of these specialized runtimes come in. Wasm 3, for example, is a very tiny C runtime for WebAssembly that runs WebAssembly like an interpreter, where it reads a bit in, executes it, read a bit and executes it, and so on. Whammer is another of that kind of interpreter style runtime, maintained by the same group that maintains Wasm time. And so you've got, and it too is designed to handle some of these lightweight or constrained device things, but with a slightly different sort of bent toward the WASI specification. Wasm Edge is one we're excited about because it was just adopted by CNCF. It's a new CNCF project. It's a JIT runtime, a just-in-time runtime, which means it loads the module. It kind of does an incremental compile of this thing and can execute it faster, but at the expense of taking up more memory. So the first two, really good for smaller embedded devices. As we get into Wasm Edge, now we're starting to broach sort of mid-tier devices. And one of the cool things about Wasm Edge is that they have been adding a lot of extensions that you can opt into and say, I would like my WebAssembly runtime to also expose an API for doing smart contracts, or an API for doing networking, or some of these other features that are not yet part of WASI or part of the Wasm core. And of course, there are others out there. A lot of fun kicking the tires on basically anything with SpiderMonkey or V8 built in. So if you head over to your friendly neighborhood Dino or Node.js documentation and search for WebAssembly, you'll find it there. So there are plenty of things to experiment when it comes to this kind of specialized runtime environment.
Now, to finish this all up, we wanted to go through our wistful wonderings, or what we hope is the future. And one of the things to point out here at the very beginning is we're still very excited about Wasm. We've been working on it for basically 2 years at this point. But even though we've been working on it for a while, it's right now, we know that WebAssembly gives us the possibility of a secure VM-like thing. That's not an apples to apples comparison there. It's just something that provides isolation with good portability and a good developer story. And we think that WebAssembly will really do that. But there's some specific areas where we really think Wasm will find its sweet spot.
Yeah, plugins is one. And a friend of mine remarked recently, and I think this is true. He said, WebAssembly might be poised to be the last plugin model we ever need to learn. And what he meant by that wasn't necessarily that it's automatically everywhere, right? But just that it might expose the right number of core services, the right cross-compile, cross-platform story, and the right amount of flexibility for exposing APIs that we could realistically see it get adopted by anything from browsers to GUI applications to server-side things. Envoy proxy is a great example of this. Envoy already includes WebAssembly runtime for extending the Envoy capabilities, and actually, so does Microsoft Flight Simulator.
Yeah, it's pretty crazy what people are doing with it. You'll keep seeing it pop up in those things. You'll also see here some stuff that we've already mentioned, like functions as a service or constrained devices. I also think that we've talked a lot about this, that WebAssembly modules will enable true microservices. Now, people will put things in a container and slap a microservice sticker on it. We're talking about true, real microservices when it's just each small encapsulated function of logic, like what I was showing in the Wasm Cloud demo, that's where we think that it will be a really good fit as well as being a good place for trusted compute, just given the security model and how you need to explicitly grant permissions for it to be able to do anything. So that was some of our guesses for the future. We could be totally wrong, but hopefully you've seen through this the many ways that Wasm is evolving and how you can get involved, and hopefully it's given you a few ideas of where you can start researching. So thank you so much for attending this talk, and we hope it was useful, and feel free to ask us any questions online, or if you are in person at the conference, in person as well.
Thanks to Microsoft Azure and Equinix Metal for supporting us at the champion level. We also want to thank Red Hat and Slim.ai for funding us at our supporter level.